So I'm really happy that this works now. I have the honor of actually like having the talk that says, okay, how to start using the radio with something that I want to do myself and not only reproduce something that someone else built somewhere. So topic of my talk is from 0 to 60 years in 30 minutes. I guess we're going to do it in 15. This is going to be fun, I hope. I have a small demo on here, so maybe this will work out. So what I am is an electrical engineer, which means that in practice nothing works. In practice there's nothing you can do. You have your tools, you have your problem, you analyze your problem, you apply your tool, you implement the solution, and then it's just like improvement by iteration. So in the end, you go from I have my tools, I have my problem, I have my solution, and in reality it's usually that's the kind of especially with the radio, which is kind of the thing that I'm here for. The reality is, yeah, you get your tools ready, then you fix the bugs in the installer of your tools, then you familiarize with your tools, and then you really understand your problem again, and then you get coffee for the third time today, and in the end, it all takes a long time to actually get a system running, but that's really how like how engineering works. So rough structure is this was my intro. Then I'm gonna quickly go over how to actually get the radio because as Daniel said, it's a package and it's available for most distros, but there's caveats, and yeah, then I'm gonna go about how to really like go and solve an actual problem by designing your own radio application, and if there's nothing that is already there to solve your problem, how to build your own tools with the radio. So getting the radio is a little bit challenging often because well, GNU Radio is a relatively big project and it does a lot of DSP stuff and it has visualization, so we got a lot of dependencies. In fact, those are just like really short excerpt, and there's a few of my favorites in there. Everyone remembers Brief, like the only project in the world that I don't know anyone who actually built the full configure, include all this features thing. And there's really a lot of problems building, just getting the right dependencies on many operating systems. Then, of course, it's like we're trying to be cross-platform, which means we support Linux, and that means look in all the right places for the different distros. We also have a lot of people that do their work on OS X, so this is a pretty popular platform, and it's pretty well supported in our community. And then we have Windows, which is also a popular platform, but not really a well-supported platform yet, I'd say. We have Geoff, who actually works a lot on that, but it's kind of like Windows development feels strange to a lot of us, to say the least. And also all the facts that in Windows development, like, you can't be sure that headers are somewhere in user include or somewhere similar. It's like really strange, and it's making it hard for us. But it's a work in progress, so if you want to help with that, that would be awesome. I'm pretty sure that we can use a lot of help with that. So what's also changing is that, you know, the radio is a software development tool kit kind of thing. So you might want to like take a deep dive, like the gentleman who asked about the textbook might actually want to like develop a feature with GNU Radio, actually fiddling with the interior workings, and not mess up his like the bread bringer GNU Radio that he uses to like do his SDR work for his employer. So this is a really often encountered problem that you actually want to have different environments on your same computer and not always spin up a virtual machine just to like, you know, try a different version of something. Well, obviously the optimal solution for installing the radio is like use your distro. Well, the distro managers, they usually, the maintainers, their job and their dedication is actually like to figure out how to build software in a way that they can package it, and they always include the right dependencies, and you never end up with something that doesn't work with the version of the library that's installed. So if you can, obviously you normally use a distro package. And the reality is, like, GNU Radio is not only one project. It's like GNU Radio, and then there's the ecosystem with a lot of people actually just write an out-of-tree module, write software that uses GNU Radio, and is maybe very useful for someone else. But it's not realistic that they're gonna end up writing like a package for Debian, for Fedora, for Red Hat, for whatever. That's really not the case in the normal sense. So the only thing that we can do is make that easy, and also have some mechanism to install that. And of course, like if you want to have GNU Radio with control port for some reason, you need first in a recent version, and you just won't get that on most distros today. It's like not very probable that it comes with that right version. And all the versions are broken, but that doesn't change the fact that Red Hat can't go back in history and just ship a newer version. And so here you are with that problem. And also, like, obviously, this is an open source developers meeting, so everyone wants to look at the code and build it themselves. I mean, aside from Gentoo people, that's really nice for if you want to look into something. Enter PyBombs. PyBombs is our, I always forget the full acronym, so this is our Python build, overlay, manage bundle system, which takes the job of knowing how to install dependencies, knowing what dependency a package, including the radio has. It knows how to install it using your distro's standard ways, or it knows how to build them from source if there is no standard ways, or you ask it to build from source. So this is really a nice tool. You can think of it as something that actually like just takes the burden of going to the website, knowing the Git repo that you have to clone, knowing how to call configure, knowing how to call make or cmake or whatever, and installs it into a prefix. And this is really interesting. A prefix is a directory where you put your stuff, and you just like point your runtime library linker, and you point your path in there, and suddenly stuff is there, and you can execute whatever GNU Radio companion, and it works. And if you don't set the variables, your Linux system or your OS X system just doesn't know that like there's other libraries in there, and it just ever interfere with operation of your normal system. So this is something that has been very, very helpful for people that run experimental software everywhere, basically, since forever also. But no one knows that. If you're a Python dev, you might have used virtual amps, so this is kind of the same idea. You basically just set the right variables, and Python knows where to look for Python modules. Getting PyBombs is really simple. I'm not going to go into detail about that for temporary reasons. Using it is even simpler. You just like say, okay, this is the script that sets all my paths, and you're done. You do that, and then you can call your radio and it starts using radio applications, and everything's there. But I mentioned that it is an ecosystem, and Ben mentioned that in his intro. We have CGRAM, and there's like a lot of out of free models, or a lot of applications that people develop are already available easily. And you can just install them by saying PyBombs install whatever PyPCAP, and then you suddenly have an interface for capturing packets with biochar in GNU Radio. So this is pretty awesome, and it eases the installation of stuff pretty much, and also it gives us like the ability to distribute something easily, have like a central idea of what's there, what's missing, and also like where to report bugs and this kind of thing. So this is a chapter break. I should have marked that more clearly. We're coming to the part where we actually go from, okay, we have GNU Radio, we have ways to install it. We have the idea that GNU Radio is some kind of, we have 5 minutes, some kind of signal processing system. But how do we get from these abstract ideas to an actual implementation? So what I did is I looked at a simple like physical radio receiver, and that's what we often think about it. It's a chain. It's a chain of, there's an antenna, there's an amplifier, there's filters, there's mixer, there's an analog to digital converter, there's a digital PLL, so in my car radio, whenever something locks onto the channel I want to receive. Then there's the FM demodulator, an equalizer, so it doesn't sound as shitty. And then there's like the digital to analog converter that goes into my microphone, loudspeaker amplifier, and then there's the loudspeaker. And so this is my whole system, and this is how I want to understand it, and how I want to represent it in the end in my software that I'm going to write, because, you know, software different radio. If you translate that into GNU Radio, then it looks kind of like this. I'm going to jump back to the last slide a couple of times. So we have the USP source or the RTL FDM source, or usually you just use the Osmocom source, which is like, yes, this guy wrote that, so which covers a lot of hardware receivers, and that has the job of like that encapsulates the hardware interface, which usually ends here. So this is all encapsulated by hardware source, and so the next thing they do is like the carrier tracking. Then we have the FM demo. This maps one-to-one to like the logical blocks that you have in mind when you're designing that system. Okay, then you have, I built like an equalizer that I could explain in 4 to 5 sentences. Like we have three bandpass filters, and everyone covers another part of the audio band. Everyone has a different gain, and we end up with, and we add them back up, so we can like change the amplitude of like the bass, the medium tones, the high tones, and then we just feed it into our audio sync, which is like everything that the sound card and everything behind that does. So this is like theory of software defined of your system converted to practice in less than 2 minutes. I have a demo, but I'd rather actually skip that, because Daniel actually like showed the same demo with GQRX, which of course looks nicer, and I just like had the same flow graph for handset radio, so that works. So this is my whole flow graph that works, and it looks like that after you click together this. So you can build an application that actually like receives the whole FM band by clicking together this in the GNU Radio Companion, which is kind of awesome. Because if you understand what you want to do, then getting from here to there is really like 5 minutes of work. This is the power of software-defined radio, and especially GNU Radio. If you've got the right tools, you can just build what you want like in a minute. So, but I have a minute left, so I'd like to point out that it's not always the case. We don't always have the tools. For example, if you want to build something really absurd, well, no one's going to be there to build that before you come there. So you invent an out-of-tree module, which is like our kind of saying, okay, this is a GNU Radio package. You can have your blocks in there, you can have your flow graphs in there, you can build your application in one directory and share that with other people. You build your GNU Radio package, and that's really easy. There we have tools. There's a GNU Radio mod tool, which is meant to like build modules. We just add a new tool, and my example for that is you can actually like build. I thought, okay, what's absurd, and I said, okay, let's do a speaking clock that says, okay, at the next beep, it's whatever, too late. Your time is over. How to do that? Okay, I'm lazy. I'm just going to use something existing and write a Python block, because you can write GNU Radio blocks in C++ with Python, and because I'm lazy, obviously I'm going to go for Python. And why do I do that? Okay, we're going to skip that point. And how should it look like is really like, I have a clock and it just says, at the next beep, it's so and so. And actually what I did then is like, okay, I make a new module, so new mod speaking clock. So, okay, I get that new module, now I change it to a directory, I add a new block, I say it should be Python, and then I add the functionality, which is like 8 lines of code at the right place.
Do you have a demo though?
Yeah, okay, so we can do that.
We will have to skip Q&A because I want to see the demo. And
Sure.
I'm just gonna say like we have to let people out of the room like more than we can let in. So I'm gonna walk over there and be a bouncer.
So the demo is really short. We can do that actually while people.
No, we can't.
Okay. Dr. Brown says so. Here we go. So maybe I should.
At the next thing, it will be 12 hours, 29 minutes, 10 seconds.
Which means I have.
At the next thing, it will be 12 hours, 29 minutes, 30 seconds.
So that works. And everything that I did was actually like write this block. Now, how does that block look like? Well, I'm. So it's the utmost ugly code that I could come up yesterday night. So it actually like it's a state machine that says, okay, am I currently emitting samples? Am I waiting for the next time to say ding ding ding? Or am I currently speaking? And then it just like plays the ding 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 song or wait. Where is it? Yeah, it actually generates the voice for the next second while I'm waiting for it, and does that by calling espeak on the command line. So this is the most stupid way to do this, but it actually worked. And it was like 20 lines of Python, and I put it into different things because I wanted to have time command, but in the end, so this is all that matters actually is in this work method, which really just takes the input sample. In my case, it was source because there's no input on the clock. Then generates output items, and I write with items whatever I want to generate, and that's how you write narrative blocks basically. So this was a really, really, really short intro to on writing narrative blocks. I'd actually rather have a little bit of Q&A, so I'm gonna contradict Dr. Brown here.
Okay, you have 1 minute, and people can start leaving the room while you can.
Exactly.